What's up, everybody? My name is Liam Monninger. I'm a research engineer here at Movement Labs. In this video, I'm going to be walking through both the Movement monorepo and the Movement Aptos core repo. Both of these are critical components and security vulnerability surfaces for the Movement mainnet. I'm going to talk through stuff both in terms of reading through the code and also in terms of running different processes and potentially tampering with things to see what you can figure out. Okay, I'm going to start with the movement repo. Of course, I'm going to assume you've already read the README a little bit. And what I'll begin on is actually the kind of transaction flow and where to trace it through our crates. So there are two kind of critically important subdirectories in the movement repo. There are protocol units, which are kind of the different modules that we actually put together to build higher order processes. And then there is the networks subdirectory. For the movement full node process, which is where the ingress of transactions takes place before things are sent onto the DA, that is defined under movement networks movement full node. And essentially, if you trace out all of the dependencies of the movement full node, you'll be able to find the different crates that you need, either in the form of there being a direct module that's included here in the process or a client for another process. Let's see, before I hop anywhere else, I think for the movement full node crate itself here, what I would suggest you take the closest look at are the DA tasks, because the streaming from and writing to the DA is a surface that can potentially be buggy and has been buggy in the past, and can kind of conceal potential attack vectors. Apart from that, just read through, feel around with the code. Okay, so the movement full node is primarily comprised of units from execution / Aptos. Aptos is movement Aptos. When we get into the fork of Aptos, I'll talk a bit about how we differ. It's not too substantial, but we have these separate crates, and a lot of what is being done in here, as opposed to being done in the Aptos core fork, is simply just pulling things out in ways that are easy to reassemble. As I'll touch on a few times throughout this video, kind of the big security vulnerability, or the thing that's been the trickiest for us, the most deceptively simple, is that we're no longer operating in this kind of hot stuff quorum certificate. You come to consensus amongst all of your replicas before closing a round of execution environment. We are sending transactions to a shared sequencing layer. We are reading off that shared sequencing layer, and then we're executing them optimistically without knowledge of consensus until later on in the process. So in this subdirectory, you'll find crates that essentially do the work of pulling the Aptos block executor out into an executor we can use in this context. Let's see. So the opt executor is the most important crate herein. There's some information on various bugs that have been compiled in different subdirectories. It's worth checking out. A lot of them have been resolved over time. New stuff crops up, of course. The kind of trickiest task, the thing that has been the most error prone in the past, has been the executor background task transaction pipe. This is a denial of service surface. It's very easy to mess up the implementation of how we're piping transactions onto our separate sequencer process, such that somebody can slip in a bunch of transactions that won't pay gas, or we overdo it, and then users can't actually get their transactions in. So this transaction pipe module and the associated background tasks that it's essentially defining are really good things to look at. Okay. Apart from that, one other thing I'll call out as kind of an interesting part of this to review is the framework, which is essentially the framework subdirectory is essentially a bunch of modules associated with testing and then actually upgrading the Aptos framework. Essentially, this is supposed to, if I go into releases, these releases are essentially supposed to prove their compatibility and be preserved in the directory. So that's something we've done a little bit different from Aptos, is we've tried to keep essentially a DAG of, okay, we can upgrade from ELSA, which was like our first ever release, to Biarritz RC1, and then Biarritz RC1 to latest. So that should be preserved here. It's interesting to take a look at how we're making the upgrades in addition to the actual framework bundle, some of the surrounding logic. But yeah, this is another point of interest, I would say. One thing that I would not spend too much time on is the fin view and this DOF executor in general. One of the big differences between us and the Aptos block executor is that we added in the ability to revert blocks. But at the moment, because we are running with one validator, we are not actually reverting blocks. And that will not change until the newer version of FFS is rolled out onto our movement mainnet. So the block reversion is taking place in the DOF executor, and the fin view is essentially supposed to be a view into the Aptos state, so a version of the Aptos REST API that only shows up to the ledger height that has been finalized. But both of those are exactly the same as the opt executor at the moment because there's only one validator. So for the purpose of this hackathon, you're not going to find anything that's really in scope there. But if you do want to take a look and point out things that could trip us up later on the road that maybe we missed, we're always happy to hear about that. Okay. So once the movement full node processes transactions in that transaction pipe, it sends them on to our DA node. And so the DA node is essentially defined in this protocol unit's DA movement subdirectory. There's a protocol directory which really describes a generic version of our sequencing and data availability stack. And then there's a providers subdirectory which contains the Celestia implementation, as well as a few like kind of composable implementations. So the disk FIFO is not in use. You won't have to look at that. Digestore is. This is essentially where we write our Celestia blobs into an intermediate store, and then we're only posting the digest to Celestia. The long-term idea here is that this becomes a full-on data dissemination layer with something like VID. At the moment, we're centralized. It's just that. So take a look at these Celestia and Digestore crates. They're important actual implementations of the overall DA protocol. It's nothing too complex, but again, this kind of thing is a bit deceptive, particularly when we're talking about addressing back pressure from Celestia and that potentially being a denial of service vector. There's a lot of kind of abstract implementation in protocol. A lot of these things are broken up kind of as layers that can be composed generically. The pre-validator and the verifier are good examples of that. Checking that those are actually being used correctly, and that kind of errors are being propagated in ways that are reasonable is something that is probably good to do as well. Okay, so in theory, once the mempool, once this DA node has gone ahead and processed transactions, it's actually I should explain that first. So the thing we use at the moment for sequencing is not purely Celestia. So we eventually send blocks to Celestia, but the nodes that are running this DA are functioning as block proposers. So the core logic behind how blocks are constructed is defined in another crate where we have sequencing. And essentially, this memsec crate is a sequencer that wraps over a generic structure that implements a mempool trait. And at the moment, the mempool trait, or the structure implementing the mempool trait that we're using, is this move rocks guy. So you would be able to trace those out from the DA, but essentially if you're just trying to look quickly at all of what is encompassed in kind of the DA at the moment, you would look at DA/movement, you look at sequencing/memsec, and then you'd look at mempool/move rocks. Okay. So that's pretty much the DA. Once transactions have been formed into blocks, submitted to DA, come back to the DA to the full nodes, they get executed, which brings us back up to that movement full node process. We do have settlement logic in here, but it's not what we're going to be rolling out on, and we're not using it in a particularly meaningful way at the moment. So it's not an attack service. It's out of scope for the attackathon. So really, when you're looking at this movement repo, it's that movement full node process and then this movement DA process. Okay, I'm going to hop back to the movement repo in a sec and talk about how to work with it at a lower level and how to run stuff. But I'm going to move over to Aptos core briefly first. Okay, so here's Aptos core. The default branch we're using in Aptos core is the movement branch. It is just a fork of Aptos core from Aptos Labs. The things we've changed are the framework and the block executor, and then just a bunch of stuff for like visibility. So when you're looking to poke around in the framework, you're just going to want to go into Aptos move, framework, and then Aptos framework. These are where all of our changes are made. There's a little bit of binding logic in Rust, a couple places, but it's just repeats of what Aptos does when they introduce new features. It's not like we're changing natives or anything like that. So yeah, changes in here. You'll see a few modules in here which are no longer in scope. So the atomic bridge and the native bridge modules were our bridge implementations that we did not roll out to move in mainnet. They have to remain in here because of Aptos upgrade rules, because they were rolled out but not turned on in ELSA. So those are in here, but they're not in scope. The most important module that we've added is this govern gas pool.move, which is essentially just this wrapper around the resource account into which our gas burns. But it changes the epilogue a bit, which is defined in transaction fee and transaction validation. So those are good things to take a closer look at, transaction fee and transaction validation. those modules also affect general transaction execution because they're run in the transaction log. Okay, so that's Aptos core for the framework. The other thing we changed is the block executor. This is spread over several crates. So I'm not going to try to pull through everything, but in general, you can check the diff by looking at the PR from movement to main. So it's quite large, but it's not insurmountable. Yeah, you can search through here and find the block executor modifications and whatnot. Those aren't anything crazy, I would say, but there is historically a lot of kind of edge cases in Aptos DB implementation. So definitely worthy if you want to poke around and to take a look at. All right, now I'm going to hop back over to movement and talk briefly about how to kind of run and work with things a bit. I will say, in terms of reading the code, using our cargo docs is going to be quite helpful. Not everything is extensively documented, but there's a fair bit that is. And it's just a very nice companion, of course, to have to working through the repo. So I highly recommend just running cargo doc, open, no depths, and having this alongside as you work through. Okay, in terms of running different processes and reusing some of our tests and overlays, there's a fair bit that's here. It's not like the most user-friendly setup in the world, but you can run a lot of things with a single command. The way we've set this up is described fairly well in scripts. The basic idea is that there's a just file which is used to essentially take a singular process command and apply a bunch of different overlays or features. What do I mean by overlays? These are what are described here and here in the README. These are essentially just different versions of the application that can run. We've given you guys the mainnet config. So in general, like the bugs that are in scope are going to be with that config, but there are additionally overlays that you can run that perform certain attacks already, and by mimicking, you can write your own attacks. To see how to write these, I would recommend just going straight to the places where they're actually implemented. So the basic idea with the overlays is that we use features of Process Compose or Docker Compose to merge in these like application compositions. And the best ones to run are the Process Compose ones because they preserve incremental builds, and our repo takes forever to build. So you can go into Process Compose. For the movement full node, you would go into the movement full node directory, and then you'll see there's this format to all the files. That's process compose dot some name dot YAML. You would be able to select additional overlays by passing these in as features to your command. So let me go back up to the top to show you an example. So for example, this is running with ETH local. So it's just movement full node. Native refers to process compose, build, setup, Celestia local, ETH local. So I'm running with Celestia local and ETH local. Okay. So you could go into process compose, and then let's say I want to figure out what ETH local is doing. ETH local is this one. Okay, so it's basically just setting up a few things to like configure something else to run as ETH local in the environment. Cool. All right, so that's the basic idea. There are, if you're looking to kind of build on attacks that we've run in the past, some attacks in here. So there's a gas DOS overlay which runs this cargo bin. There's a test of follower consistency. Where is it? Test followers. That's pretty handy to build on for different kinds of network forking or inconsistency conditions. A lot of this stuff is stitched together with utilities that are worth trying to find bugs in, particularly those related to syncing. Um, in test followers, you'll see this movement sync environment variable. That's something that's good to trace through our code and take a closer look at and help you understand how we're doing kind of the follower node syncing and whatnot as well. There's also tests for the upgrades in here and so on. So this is a great place once you get a hang of the repo to start to look at different things that you can do with the processes and potentially kind of implement replicable attacks and tests of your own. So that I think is where I'm going to leave it for this video. I hope that's helpful. I know this video is coming in late, but I hope this adds a little bit of extra information that helps towards the end here. So thank you all for taking a look at our code so closely, and all the best.